Quantum physics is one of the most fascinating and misunderstood areas of science. Its strange principles, superposition, entanglement, uncertainty, often sound like science fiction, and this has led to countless myths and misconceptions. In this video, we will bust some of the most common quantum physics myths, explaining what is true, what is exaggerated, and what is completely wrong. A very popular myth is that quantum physics proves that consciousness creates reality. Some people claim that observing a quantum system collapses it into reality because of the human mind. In truth, measurement in quantum mechanics does collapse a quantum state, but this has nothing to do with human consciousness. Any interaction that extracts information from a system, whether with an instrument, a photon, or another particle, acts as a measurement. The role of human observation is a philosophical misunderstanding, not a scientific requirement. Another widespread myth is that quantum entanglement allows faster-than-light communication. Entangled particles do exhibit correlations instantly over any distance, but this does not transmit usable information faster than light. The outcomes of measurements are random, and only by comparing results afterward through classical communication can correlations be confirmed. Entanglement is remarkable, but it cannot break the cosmic speed limit. Many people also think that Schrödinger's cat shows a cat being alive and dead at the same time in real life. The famous thought experiment illustrates the paradox of applying quantum superposition to macroscopic objects, not an actual scenario in a lab. In reality, decoherence prevents large systems like cats from existing in superposed states. Schrödinger's cat is a metaphor for quantum principles, not a literal experiment. A related myth is that quantum mechanics means anything is possible. While quantum physics allows probabilities that defy classical intuition, it does not allow miracles or arbitrary outcomes. Particles cannot teleport randomly across the universe, or violate energy conservation, or create objects from nothing. Quantum rules are strange but strict, and they govern what is physically possible at the smallest scales. Another common misconception is that quantum mechanics invalidates classical physics. In truth, classical physics is an excellent approximation for large systems. The laws of Newton, Maxwell, and Einstein still work perfectly well in everyday life. Quantum mechanics does not contradict classical physics, it extends our understanding to scales where classical models fail, such as atoms, electrons, and photons. Some myths arise from quantum terminology itself. Words like wave-particle duality or uncertainty are often misinterpreted. Wave-particle duality does not mean particles are literally waves and particles at the same time. It means that particles exhibit behaviors that can be described by wave-like equations or particle-like interactions, depending on the experiment. Similarly, Heisenberg's uncertainty principle does not mean that the universe is random or that we can know nothing. It simply quantifies fundamental limits on how precisely certain pairs of properties, like position and momentum, can be known simultaneously. Another myth is that quantum physics supports mystical ideas, like the law of attraction or universal consciousness. While quantum mechanics is counterintuitive, there is no scientific basis for using it to justify metaphysical claims. Its principles are strictly physical and mathematically precise, applying only to particles and systems at microscopic scales. Quantum computing has also sparked myths. Some claim quantum computers can instantly solve any problem or predict the future. In reality, quantum computers provide speedups only for certain classes of problems, such as factoring large numbers or simulating quantum systems. They do not offer omnipotent capabilities, and they cannot replace classical computers for everyday tasks. Understanding these myths helps clarify the real power and limitations of quantum physics. It is not magic, but a precise and predictive framework that governs the behavior of the microscopic world. Its strangeness does not imply arbitrariness, and its rules are consistent, reproducible, and testable. In simple terms, quantum physics challenges our intuition. But it does not defy logic or reason. By separating myth from reality, we can appreciate its beauty, its applications in technology, and its deep insights into the nature of matter and energy. Debunking these myths is also essential for education and communication. Misconceptions can lead to confusion, pseudoscience, or unrealistic expectations. Recognizing what quantum physics actually says allows scientists, students, and enthusiasts to explore the field responsibly and with wonder. In the end, quantum physics is strange, surprising, and sometimes hard to grasp, but it is not magical or mystical. By busting these myths, we can see it for what it really is, a revolutionary understanding of the universe at its most fundamental level. With real-world applications in computing, cryptography, materials science, and beyond.